You didn't do homework either?
I forgot to bring it. I looked at it. I had no idea.
It's hard. It's one of the hardest things.
I realized it was on stream. I know.
Hard because it's like I'm gonna be honest. This one was really confusing for me. I did it in a different way.
Oh, when is
So
that?
it's pretty much
Trying to do the thing together?
reflecting this area over the axis.
Corbin,
Just what?
did you ever upload the video?
I did.
Where?
Oh, what the? I mean, it's only Google Photos.
Oh.
No video back.
No, media. I didn't know
I got hot.
Okay, so tomorrow.
You have to talk. You have to use two intervals.
Afternoon, 3 to 5.
Yeah. Because it's the same thing as if you do.
Yeah.
Yeah. Because if you look, if you think about it the same as the area of curve.
All right.
This is a different right, and this is a different right.
So some of you guys are wondering what a SAT day this week. I'm gonna do it tomorrow from 3 to 5. I'm gonna send a message to parents, kids, all the people who sign up. So people who didn't sign up, I won't send it. So you're more welcome to come here, and we're more welcome to work together and talk about different things. The things I'm gonna put more emphasis as about, that I feel like the trends is a lot of more exponential questions. So you need to learn how to do exponential questions. You need to learn how to do, like, I will teach you how to do regression on a calculator, because I can predict a function, and it's very useful tools. Definitely use a lot more decimals on this SAT. You're gonna find out
Is the regression where you do the table and then it like does the line for it?
they not only do line, they do parabola too.
Yeah. I made it where it was like, oh, I just made a really complicated equation. It was like.
Yeah, they will do regression. They'll do a lot of things. They will do mean. They will do median. They will do a lot of things. So, yeah. So for that part, make sure come in. Now, Ria did post a very nice handwriting one on the WhatsApp. So my handwriting just much worse than hers. Her handwriting is actually nice. So somebody posted it. Just kind of like a procedure. How do you look for things? Okay. Chase, what are you looking at?
Look at the procedure thing.
Okay. So I'm gonna guide you through a couple questions. So draw the diagram with the bounds. That is the first thing that you have to do. Pay attention to me first. It's well worth it. Second thing is draw the axis rotation. Always draw the axis rotation. Do that circle mark, that rotation mark. Third thing, draw a line or lines. So if it's a one line, it's a disk. If it's two line, it's a washer from that axis of rotation. Number 4 is decide are they dx or dy. So dx is going to be a vertical slice. Dy is going to be a horizontal slice. But number 3, and let's go back to number 3. When I say draw a lines from axis of rotation, I mean from axis of rotation. You have to start from there, draw to the bound. And you might draw to 2 bounds, and then that's going to be a washer. 5. Decide disk or washer. Then disk washer, then I would say, okay, well, if the disk washer, if the disk, then it's going to be only one radius, which is the big R. The washer, there's 2 radius, so it's big R and a small r. 6, correct boundaries. So that means the upper bound of the integration and lower bound of the integration. So if you do it in terms of x, has to be x bound. If you do it in y, has to be y bound. Does that make sense so far? Okay. Now, number 7, I put a double start market on it. There's a reason for that. If I ever had y equal to something, like y equal to x squared, for example, That means distance from an x-axis to the x squared. Okay, if my x has something, let's say x equal to square root y, is distance from y-axis to that function, to the bound. And that's very important because on some of those questions today on your homework, you're really gonna have issue with. Well, over Friday, the homework. Number 8, there's certain thing you should not forget. Don't forget the pi in the front, ever. Because pi in the front, if you forget, that's a wrong on AP exam. Don't forget a square sign because you need a r square. Some people, they just forgot the r square. The third thing is don't forget a parenthesis. Every time you substitute something, put a parenthesis. Fourth thing, dx or dy. So don't forget those things when you set it up. Because on AP exam, I only care about setup. On my test, I only care about setup. The evaluation for other things. Because sometimes it's really hard to evaluate other things. On AP exam, only setup only. Because you're going to use a calculator to do the rest. Your homework on Friday, you should use homework to set up. You should use calculator to set up and do it for the rest. Okay, so let's start with question 9. Nine A is pretty easy. So anybody got 9B in this classroom? Ethan, did you get 9B?
I think so. I can check to see if I got it right. Calculator on my dresser. I might have. That's nice.
So 9A. Simon, you should start doing your homework. But I don't know what to say. You show up to class, great, but I need you to do work. I know you think you get in UCF already. You don't care about anything. You don't care about grade, nothing. 9A. 9A is gonna be x squared. So this is a graph like this. Okay, so this is y equal to x squared. And this one is gonna be this. Now I only care about this region. So do you guys know what a graph look like? Or do you guys know the rotation look like? If you guys know the rotation look like, if you don't know what it look like, I'm gonna try to send you something to help you. So hopefully I can find it. There is. Copy link. I'm gonna post on WhatsApp. Okay, so I posted a link on WhatsApp. And this link is gonna be this. So what I did is if I see this, it's a 4 minus x squared. Do you see that? And you say g of x is equal to x squared. Okay, so I'm gonna zoom in a little bit. And I'm gonna change your orientation to look at this. So this is how the rotation, this is a graph, right? A little bit change the vision. So if I put it in this way, let's say if I put it in 0, it's gonna look like this. That's the actual graph that we graph. But I'm gonna turn a little bit. And I'm gonna show you the rotation. So it's gonna rotate around here. It's look like a satellite dish. Do you see that?
Whoa. Oh, that makes sense.
It looks like a satellite dish.
What's that big blue thing?
That's the graph of the bounded graph of x squared and the 4x minus x squared.
It's like going around.
Yes, yeah, it's going around x-axis. So you see there's the outer radius is the blue line. Do you see that blue line? And do you see the inner radius is the green line? And basically it's like a satellite dish covered this way. So it looks like, if you look from the other side, let's say look at from this side, it looks like a satellite dish.
But what's the green one?
The green
That's the
is
individual.
the green line is the inner radius. Okay, so we try to find a
How
value.
did you do that?
How
Huh?
do you do that on Desmond?
I sent you the link already. It's on WhatsApp.
What if inner radius?
Desmond's
Inner radius. Like there's a radius of like that's
So cool.
So if I like say watermelon, if I cut off the slice and I rotate them, instead of just let it rotate the whole slice. So the inner radius is the empty spot, the hollow spot I cut off.
Oh, I see.
Okay, so this is the things that I send you a link. You can type in the top function, the inner function, outside function there, and you can see that rotation. So basically, you can play with it if you want to show you that unfortunately this decimal can only do x-axis and y-axis. It does not do off-axis because off-axis takes a lot of programming to make it work. Maybe some of you guys are smart enough can purely port it up with.
I mean, in fairness, that's already a ton. Like,
Yeah, that's a lot of programming right there. Okay, so now what do I do is I'm gonna draw. So I finish your first step, right? What is the second step? Draw
the line.
a axis rotation.
Oh.
So the axis rotation is right here. Draw that. Okay. Third thing. Going from here, draw from the axis rotation. Like you see, this is bounded graph. This is the region that I'm more worried about. But I'm gonna draw from axis rotation to the graph. So first thing, I'm gonna draw it to here. Do you see that? The second thing is I'm gonna draw it from here to here. So you see that the inner radius and the outer radius. Now this is a vertical slice. Is that dx or dy?
Yeah.
Dx's. So start with dx. I write down. And start write down washer because there were two lines. Because sometimes this disk, it's only one line. If I only go to the boundary, so for example, Chase, you're not here. Let's just say if I have a equation going like this, and if I draw from axis rotation to here, that's only one line. So that's a disk. So that means one rotation is gonna be a circle, and this is the disk is r squared. And multiplied by 5, that's gonna be your integral is basically you adding up all the things here, and you integral like as a value. Yeah, like a football.
I feel like is it usually like when there's two functions, it does two lines?
No, not necessary. You can have two functions. This is one line. Depends on how they rotate. So, the function could be x equal to 0. So it's two function, and it also depends on where the rotation is. So in this case, it's gonna go here, here, and here, here. So you probably have to come up with the score to work. Okay, dx, and washer, and the boundary is gonna be what? 0 to 2. Why 0 to 2? Because this is the x bound. You start doing integral from here to here. You stop right here, and that's 0 to 2. Now washer, you're gonna figure out that's a big R of x and small r of x. The big R of x in this case is the function for the blue line. Is that okay? Because that's the distance from the x-axis to the blue line. Yes. Top minus bottom, yes. Or bigger radius. So this is the bigger radius minus small radius. I think that's better instead of do top minus bottom, but in this case, top minus bottom this works. So this one's gonna give you 4x minus x squared, and this is an x squared. Is that okay? So I'm just write down. Remember all the steps here. I'll refinish all the steps from, let's just say from here to here, I'm gonna copy. And I'm gonna paste right here. But I'm gonna shrink this small. So paste, and I'm gonna shrink to really small here. Okay, so like this. So that way I can see like which step already finished. I already draw the axis rotation. I already draw the axis rotation. I already draw the lines. I already decide this with washer. I already decide washer. make sure the correct boundary. I already do that, 0 to 2. Now, this one here, y equal to something, which is that told you the distance from something to something. In this case, we kind of don't need it, but that's okay. And don't forget pi, so don't forget pi here. Pi must be outside. And the outer axis is going to be what? Parenthesis minus x squared, parenthesis dx. What did I forget? Square. And so you must have that squares. And if you do this correctly, this is how you get an answer for this particular one.
On the test, do we get to have a calculator to evaluate it, or do we do it by hand?
I will ask you setup only.
Okay.
I won't ask you to evaluate it with a calculator or by hand.
How do you know how to name like the functions like with capital R, lowercase r, like so you can
The r is a bigger radius, so this is a bigger radius. The longer radius here, this is a smaller radius.
Okay.
So big R is going to be the big radius. Now, we also did one that's off-axis rotation. Okay, so this one is off-axis rotation here. So this one is the questions. So 9b. Some of you guys didn't know how to do 9b. Ethan, did you get to 9b?
I did get it
Okay, good. Ethan, I'm kind of proud of you recently. You put in some work. So I'm going to rotate around here. Okay, I'm going to rotate around here. Now, what's my next job? Draw from where? From axis rotation to the boundary, right? So now you see this? This is a one bound.
What's the axis of rotation?
And this is the second bound. Do you see that? The problem is, let's go back and look at number 7. What did number 7 says? Number 7 says y equal to something is distance from x-axis to the bound, right? So we got this one is y equal to x squared, but the problem is that's distance from here to here. That's not exactly the red line. Do you see that? And there's a function here is the blue line. This one is going to be y equal to x squared minus 4x. Again, that's a function from here to here. Four x minus x squared, sorry. So it's 4x minus x squared. But the problem is 4x minus squared is from here to here. There's an issue because that's not exactly what I'm looking for. I'm looking for the line on the top. So I'm going to draw out another black line here. This from here to here, this is total 6 units. There's a way to get a green line and a red line. Again, we're going to write down the integral here. For here, it's going to be 0 to 2. The pi is going to be outside. Now, okay, so let me decide what everything is. This is definitely dx. This is definitely washer because there's 2 lines. This is definitely between 0 to 2. The problem is washer has a big radius and it has small radius. So what is my big radius? X squared? No, it's not right. It's not x squared.
No, I didn't say that.
X squared minus 6.
It's not x squared minus 6 either. No. 6 minus x squared. Why is that? It's the black minus the orange. Sorry, I meant to do orange. Black minus orange. Because black minus orange is going to give me green. Do you see that? If I take the black line minus orange line, it's going to give me a green line. And the other one is going to be this way. I should not use the same color. Don't use orange. Oops, my bad. I'm not gonna use orange. I'm gonna use purple. So it's from here to here. Again, that is 4x minus x squared because that's y equal to something. That's the distance. So r of x here, in terms of big R of x, is actually 6 minus x squared. Does that make sense? It's a black minus the orange. Catherine, you okay? Maddie, you okay? Madeline? Kevin? Good? Okay, what is small r of x here? 6 what? What's wrong with this? This is wrong. It doesn't have a parenthesis. Thank you. You must have this parenthesis. So it will be 6 minus x squared, parenthesis, minus 6 minus 4x minus x squared, parenthesis square dx. So that's a proper way to write it, and you're not going to get a wrong answer if you like this.
Wait, why is that parentheses again?
What?
Why is there like 2 parentheses? Because you're subtracting the whole thing with a negative distribution. What if you can you distribute the negative sign before?
You can distribute negative sign, but don't do anything tricky. So for me, just put a parenthesis, subtracting. Just put an extra parenthesis on your calculator. You're gonna get a right answer. If you distribute wrong, then it's wrong. So just keep a parenthesis, keep a substitute. And you should get a right answer for this case.
This year, thanks, brother.
Yep. Now, there was a question 6. I think 6b, a lot of people are confused. 6b is basically, there is a function like this. There was 2 to 4. And there was a function from here to here. And there was a function from here to here. But the problem is, there was another function from here to here. And they say axis of rotation. So the problem with this is like a hollow cylinder, but it's very sharp on the top because it cut off this way. Does that make sense? So it's gonna be like this. So it's rotating. So it's gonna be sharp on the top. It's a hollow cylinder, but it has that part. So the problem is, on those 2 parts you had to break down. You had to break down 2 integrals. Do you see that there's 2 integrals happening? One is this part. Because you're going to do integral between 0 to 2 first, and then 2 to 4. So they are 2 separate one here. So one line here, one line here. So this is a big R and small r here. So this is a washer, but it's going to be stopped at 0 to 2. Because in terms of 2 to 4, then you got 2 different lengths. This one's constantly changing. This one's not changing. So you had to worry about what is the first blue line, the second blue line for this, the 2 different integrals. So you have to set up 2 integrals to rotate.
Can you explain that again? Or why we need 2 integrals?
Because you need to rotate this part, right? This part has inner radius and it has outer radius. Now, when you get past here, the inner radius start changing.
Yeah.
It's getting smaller and smaller.
But the back one doesn't change.
The back one doesn't change. So the big R stay the same. The small r is changing. Why is that? Just think about which volume is going to be bigger. The bottom part is going to be bigger or the top part is going to be bigger? Bottom part. But bottom are just a very simple cylinder.
So how do we like?
But in this case, it's not a simple cylinder. It's not a hollow cylinder. It's cylinder with a dip, yeah. So it has like a trapezoid shape, or not even trapezoid. It's a trapezoid rotation. So it's gonna be like, I don't know, some type of pie is carved out.
Dusty did it.
Huh?
Like Dusty did it.
I have no idea what's that.
It's a Fortnite thing.
That's like hole in the ground.
No idea what is that. Okay. I'm gonna use that term.
Makes sense to me.
It makes sense for Chase. Anything Fortnite makes sense. I should explain everything in Fortnite. I'm gonna ask ChatGPT to explain everything in Fortnite in terms of Fortnite terminology. Huh?
So that okay,
Hold on, let me try it.
Real AI celebrities playing calculus.
They're pretty funny though.
It's not seen the Fortnite's a masterpiece. It's like spice. Wait, I think it.
You know,
Just loading the next ABC script. You can use that for that cube.
Kevin Hugh, yeah. Mr. You should do a Jackie Chan any calculus.
he already knew it.
You understand anything coming out of my mouth?
You doing Jeremy Lin?
Can you do it?
Jackie Chan, stream all in one.
I like perspective. It's fun. All right, so try the rest of the question. Follow those steps. That's a very idiot-proof way to do it. Anybody can do it. You just have to try it. But this one you need to integral. The reason why you need to do the integral because the inner radius is changing. It was stationary. It was a constant. But inner radius is changing to smaller and smaller. So try out the question. Those of you guys haven't tried it, you gotta try it. Just type in the calculator. It's not that hard.
The one we're doing, what number is this?
Yeah, what function?
This one's 6B or 6A. 6A is a desk rotation. So 6A, Chase, 6A is pretty easy. Basically, that's a rotating around x-axis. X-axis only one, is that's where the desk is.
When do I know? It's like when you draw like the axis of rotation, right? Is it always counterclockwise?
It doesn't really matter. You could go this way or this way.
So what do you can do?
I know this one is top on the spot where that's pretty confused on.
You need two different ones. You know.
Yeah, because they split up the thing, so it's like a triangle and square.
This is how I did it. This is what I did. I got the right answer. Because this equation right here, the reverse of this equation is going to be from negative 2 to negative 4. Wait, what did you? Did you write down?
Yeah.
Can you come explain number 6 to 8 to 1? I got it. I just can't find it. Wait, B.
It's where
I always split it up. And then this.
so
So if you do rotate on the
speed or bounce because you're only doing this, so this isn't part of it.
You know, I was on the arrows.
So if we have it like this, then you can only